Good evening, everybody. We're going to do something a little bit different today. Today we are going to watch this video. I'm going to be watching it with you. It is pre-recorded. You're going to have to excuse me if I'm a little off in it. I recorded this video earlier. There was a problem with my mic. It had no sound, so I actually had to re-record everything. So if I missed something, I'm sorry. Please comment. We'll make sure that we cover it. That said, this is part 3 of normal distribution. Part 2 was cut a little bit short because of some streaming errors, but that's okay. We're going to finish part 3 today. It's going to be awfully short though. So that being said, since it's going to be awfully short, what I'm going to do is at the end of this video, I'm going to post a link to a Zoom classroom. So if you guys want to hop in the Zoom classroom and hang out with me for a little bit and talk about some code, you guys can show me what you're working on. If you have any questions with code, I can help you with that. It will be there for you guys to use. So we're going to kind of mix Tuesdays and Thursdays a little bit together today and see what comes of it. So if this is your first time here with the normal distribution project, that is okay. We always try to create something for you guys to start with, so we have done that today. We have the code that we've been working on the last 2 weeks for you to use and continue working with today. So let's get started with that, and let's pull up our old code. So first thing we want to do is go to scratch.mit.edu if you haven't already. And inside Scratch, we have this search bar at the top. In the search bar, we're going to type future of code. Just like that one word, future of code, and then hit enter or return on your keyboard. Now what this is going to do is this is going to pull up some of our shared projects. I don't know why this does this, but it doesn't always show all of our shared projects. So what you'll do is go to one of our names here where it says future of code and click on the name. Don't click on the name of the project, but click on the name of our user. And that's going to take you to our main page. And the first one here, if I hover over for a second, it'll say normal distribution part 3. Let's go ahead and click on that. Now this is where you're going to actually go ahead and remix it. Up in the top, once you're signed in, you should be signed in. There should be a box here that says remix. Go ahead and hit remix. Remix is going to allow you to make changes and save them back to your account. If you try to work on this on my account, on Future of Code's account, you are obviously not signed in as that person. It's not going to save any changes you make, so when you close Scratch and open it back up, everything you've done will be lost. So make sure you hit that remix button. Once you've hit that remix button, let's go ahead and click the button that says see inside and take a look at the code here. Now we're going to look at my work in progress code here in just a second. Excuse me. But one thing you'll notice here between my code and the work in progress code is that I've already removed all of these variables here. We talk about these variables a lot in part 2. I definitely encourage you to go back and watch part 2 if you haven't seen it already. Part 2 is valuable, especially when it comes to learning about variables. We are going to work with the variables today. I'm not going to explain them a whole lot because we go into a lot more detail on what they do and show examples of what they're doing in part 2. So go ahead and check that out in part 2. But what we want to do is we want to make this look pretty clean. You'll notice that my work in progress here is very clean. We want to be able to see all of what's going on. You do this by going and clicking on variables, and then everything with a blue checkmark box, you're going to uncheck. You'll notice that one of these says bucket : clone ID. That means that when you see bucket : or any name there, colon, that's the variable is only in that specific section. So if I go to bucket here, the clone ID only shows up in bucket. It doesn't show up in any other sprite. So you got to make sure you go to bucket to get rid of all of those to make it nice and clean. All right, once you do that, let me show you what's going on here, and I'll talk about what happened in part 1 and what happened in part 2. So when I click the green flag here, you'll see that the ball drops and it's bouncing around inside these pegs here. So in part 1, what we did was we created the pegs. We had these laid out. This is the code you can actually see right here. We had these laid out, and we do it all programmatically, so it lays them out in a nice uniform fashion. And then what we did by the end of part 1 was making sure that the ball dropped from the top to the bottom but we didn't have it interact with the pegs at all. So in part 2 of this program, we went in and we actually had the ball start interacting with the pegs, and then we created the buckets down at the bottom here that catch the ball. And once it caught the ball, it returns it back up to the top. Now what we're going to do in part 3 is we're going to do a little bit of drawing here. We're going to make these sprites draw on the background so that it represents and shows us a graph of how many times the ball lands in that bucket. And I'll talk about this a little more at the end so we understand what's going on here. This is actually a common, it's called normal distribution. It's very common in nature. We see this in certain other shapes and algorithms in nature. This is one of them that we see. And so we want to talk about it a little bit. We want to create it and see how it works in action. And this is a very prime example of how it works. We also talk about that a little bit in part 1. So first thing we're going to do, let's get started here. Let's go into bucket. Now, as I said before, we've got most of this done. We just need to create the drawing on the background. What we're going to do for the drawing is if you go down to the blue box in the bottom left-hand corner, let's add an extension. Go ahead and click on that. And this gives us a list of extensions that we can choose from that do all sorts of things, from working with microbit to Legos to video sensing, all sorts of stuff. But we want this second one in here that says pen. So let's go ahead and click on pen. And what this will do is this gives us another set of code blocks that we can use. Now, with any program that we start, we want to initialize it first off. So the way that we can think about initializing a pen is how we would work with a whiteboard if we were using a whiteboard. What we want to do is when we're using a whiteboard, we're going to write on it. We're going to lift the pen up. If we're done writing on it and we don't want what we wrote there anymore, we're going to wipe it down and then we'll put the pen back down. So the way to think about this with initializing is that let's assume that somebody's already written on the board. And let's assume that person was us. We are writing on the board. Now, if we want to stop writing on the board and get rid of it, we have to go from that position. So our pen is on the board and we've been writing. What we need to do is we need to pick the pen up off the board. We need to grab the eraser and erase it. And then we can choose our next pen or the same pen, and we can start writing on the board again. This is very similar. These habits that we do in person are very similar to the habits we're going to make in our program here. So let's create the initialization section. This is what happens when the program starts. So the first thing we want to do is, like I said, if we're writing on a board, the first thing we do before we erase is we have to pick the pen up to erase. So go to pen tool, and the fourth one down is pen up. Go ahead and drag that in. And what this will do is it'll make sure that any pens that are used in our program have been picked up and cannot draw anymore. The next thing we will do is the very first one. It is erase all. We're going to erase everything off the background. Now the next part is just for aesthetics. It's just to make it look nice. It's to make it stand out a little bit against the other colors. Is we're going to make the size of the pen a certain size, and we're also going to make it a certain color. So what I want you to do is at the very bottom of pen, there is set pen size to 1. Go ahead and drag that out into this center block, or the center area where we've been building our initializer blocks, and go ahead and drop that at the bottom, but change that to 20. That'll make our pen a bit bigger. It'll make sure that it shows up and it's not hidden behind anything else. And the last thing I want to do is I want to set pen color to, and I'm going to drag that out. And I'm going to change this to a red. By clicking on that blue, I can drag these around. I'm going to set my color to 0, my saturation to 100, and my brightness to 100, and it's going to create a bright red for me. So this is actually all we need for initializing. It is super simple. Like I said, just think about what you do when you're drawing on a whiteboard or a chalkboard or anything of that nature. Think of the actions you take, and that's about the same actions you want to take when writing this code. Now, we need to put this in a special space, and I always put it anytime I'm working with a pen, I always initialize it make sure everything's cleared before I move anything. So this is going to be my key here. As I go through my code and when green flag is clicked, the first thing I look for is movement. And sure enough, right after show, I have go to X and Y. I want my code that I just wrote for the pen to go right in between the show and go to X and Y. So what I'm going to do is I'm going to grab go to X and Y and I'm going to drag that away. So I split that code base in two. And the reason that you don't want this down is imagine trying to erase and having the pen accidentally down still. You're going to create a bunch of mayhem if you're trying to move stuff around while erasing if the pen is down. That's why we want to pull the pen up and erase everything and do everything we want to do before we try to move anything. It's hard to explain, but if you play with it a little bit, you'll see there's some funny things that happen when you try movement when you're trying to do pen up and pen down. And I'll show you kind of how that works here in just a minute as we make our buckets actually draw our lines for us to show how often a ball is hit it. So go ahead and take this pen up, pen down, or pen up, erase all, pen size to 20 and pen color to red, and drop that right below show. And then we're going to attach the go to X and Y right below all of that. And that's the big first part of what we've done. It's not too bad. So it's still going to create the same thing. We're going to see everything look just as it should. And it looks good. Now we just know that we have some pens that are ready to use. Now this is where we actually start to use the pens. At this point, we actually need to tell the clones that each one of them has a pen, and then we're going to move these clones around, and I'll explain that in a second, how we move them to draw the graph. And the clones I'm talking about are the buckets all at the bottom here. So what we're going to do is we're going to give each one of these clones a pen, and how we do that is we can tell the clone it has a pen by saying pen down. So we're going to tell it to draw by saying pen down. So go ahead and grab pen down and drop it in the when I start as a clone, drop it right before the forever. So it'll say add 0 to buckets, pen down, and then we have our forever loop. This is going to tell each clone to put the pen down on the paper and be ready to draw something. Now what we're going to do to create our graph is we're going to make it to where a bar comes up and the bar will be as tall as how many times the ball has landed in it times 5 pixels. So we're going to say each time a ball lands in there, draw that red line 5 pixels taller. Now the way we do this is by moving sprites around. So the way to imagine a pen tool being used is that there is a pen sticking out of the bottom of the sprite and facing the stage here. And what happens is when that sprite moves and the pen is down, it's going to draw on our background and leave something behind. Well, what we're going to do here is we're going to, like I said, each time it moves, or each time a ball hits it, we're going to make it move 5 pixels for each time the ball has hit it previously plus the current one. So what we're going to do is we're going to move the sprite up, but then we need to actually move it back down. So each time we're going to just pop it up, pop it back down, and that way it can draw on the background and give us a nice little graph. And you'll see here in a minute what I'm talking about as we start to build it. So what we do is we need to know what bucket has been hit. We know that by our clone ID. If we watch part 2, we talk about clone ID and what it does. Each bucket is given a specific ID. So we need to know which bucket has been hit, and then we need to know how many times that bucket had the ball land in it. And we have that in our buckets list here. Our buckets list keeps track of how many times the ball has landed in each specific bucket. And then what we're going to do is multiply that number that we collect by 5, and we're going to change where the position is in our Y direction. So let's start with the first part. We need to know which clone it hit. Well, we know that's in variables, so let's go to variables. And we keep track of that by clone ID. Clone ID tells us which bucket is currently being activated. So in clone ID, we actually use clone ID in relation to the buckets list that's down here in the make a list section. And if we put clone ID against if we say, okay, look at location 1 for bucket 1, look at location 2 for bucket 2, each one of those list items actually returns the value to us of how many times the ball has landed there. So if we go to make a list section, so go to variables, scroll down to the list section, and there will be a pill here about halfway down that says item 1 of buckets. Go ahead and drag that out to our canvas. And what we're going to do is we're going to replace that 1 with clone ID. So it'll say item clone ID of buckets. So essentially it's telling the list, hey, this is which clone I am. Tell me how many times a ball has landed in my bucket. And that's going to return a number to us. So this one says that clone ID 7 has had the ball land in it 2 times. Now, like I said, we need to multiply this by 5. We're going to move it up 5 pixels each time. So if the ball is landed in it once, our line is going to be 5 pixels high. If a ball is landed in it twice, it's going to be 10 pixels high. 3 times, 15, and so on. So it's all going to be a multiple of 5. So let's go into operators. And in operators, we're going to grab the third one down, which is a multiplication symbol. As I said, we're going to multiply 5 by the number that we get out of this. So let's take the item clone ID of buckets and drop it in that second spot. Now what we want to do is we want it to move up in the Y direction each time this bucket is hit. So let's go to motion. And we want to use change Y by 10. So grab change Y by 10, which is up and down is Y. And we're going to replace that 10 with this equation we just created here. The 5 times item clone ID of buckets. So it'll say change Y by 5 times item clone ID of buckets. Now go ahead and leave this here for a second because I want to show you what this is going to do. So don't do what I'm doing, but I'm going to show you. I'm going to restart the program here. And what it's going to do is you can see as the ball hits here, each time it hits, it's going to move that up. Here's a problem though. If we keep moving that bucket up, it's actually the ball's going to hit that bucket sooner and sooner each time. Now this is going to cause some really, really bad behavior. And you'll notice, as you can already see, there's some really awkward bugs coming out, and if it goes another direction, hits that big one again, it's going to create a really bad bug where we're going to see the ball actually float sideways. We don't want to see the ball float sideways. That's not what it's supposed to do. There's another bug. There we go. It starts to float sideways. So what we want to do is these buckets, we want them to draw the line, but we don't want them to actually stay where they drew the line to. So what we're going to do is right click on change Y by, right click on that blue block, and you're going to have 3 options. There's going to be duplicate, add a comment, or delete the blocks. We want to duplicate this, and what we're going to do is drop it right below so these 2 are together. But since we're moving positive Y, we also want to move back down to negative Y, because all we want to do is draw the line, but we don't want the bucket to move from where it started from. We want it to go back to where it started from. So we're going to change that 5 to -5. Now you can go ahead and drop this right into that if statement. So inside the forever loop, inside the if statement, right below broadcast, drop these 2 blocks. And I'm going to show you what this does. Don't do what I'm doing now, because it will cause a problem if you keep it this way. But I'm going to take a wait, and I'm going to show you what this does. I'm going to restart the program here. What this does is it's going to move up, and then it's going to drop back down. So you see how the bucket moves up and then goes back down? This makes sure that our bucket is always in its starting position. So check that out. So then we're drawing a line, but we're not actually going to be interfering with the functionality of our program. So this is actually the entire code. This is it at the moment. If you let this run, you'll see that it kind of creates, this graph will end up creating a pyramid shape. As I said, we see this pyramid in other things. Specifically, one of the things that I like to do is encourage you guys, go and test this at home. And you can test this with some pen, paper, graph paper, and 2 dice. And I'm going to show you, here is actually what it looks like if you were to try to create this with 2 dice. And what you do is you roll the dice, and then you try to figure out which number it is. And then you graph how many times you get that specific number, when they're added together. So if you roll 2 dice, you have a very low likelihood of getting 2 twos, or 2 sixes. So a total of 2 or a total of 12. But if you look at 7 here, 7 is in the middle. There are more possibilities or more combinations that create 7. So you're actually more likely to get to roll a 7 if you roll 2 dice than you are to roll anything else. And this creates the same thing that we're going to see here with this. If we let it keep going, it is actually going to create what's called a normal distribution, where the ball will actually hit the center more than it'll hit any other spot, and it's going to hit the outsides less. So very interesting. Let this keep running. You'll see what's going on. This is the end. I'm going to post that Zoom link. If you guys want to join me, you're more than welcome to join me. I really hope this video gets up in time. I'm going to load it up right now. I feel really bad that it might be late again. I cannot believe that my microphone didn't work last time. Such a bummer, but technology, it happens. It's been rooting against me lately, I think. So also Tuesdays, I know a couple of you guys sent me messages on Tuesdays. I learned from the person helping run our social media that until you guys send me that first message, it actually doesn't notify me. I have to go in and say, yes, I accept to talk to this person before it'll start sending me notifications that you sent me something. So I know I missed talking to a couple of you people on Tuesday. Couple groups of you people, I mean. I'm really sorry about that. I am learning this social media thing as we go along, so I hope that I get better at it. I think I'm getting better at it, but we'll keep working on it. Those people who have talked to me on social media already, I've accepted you. It is notifying me when you guys send additional comments now, so very happy about that, but very sorry that there was a hiccup there. It happens. I hate to admit it, but we're learning as we go along here. This is not typically how we run our organization. We're not usually all on the internet, so learn something new every day. Anyway, I'm going to go. I will hopefully talk to you guys soon. If I'm not going to talk to you guys soon, please go be safe, be healthy, and please try to enjoy the sunshine while we have it. It was nice out today. Go play outside. And I hope to have you guys with some more videos here soon. And at the very least, I will talk to you later. Thank you guys again. See you soon.